My name is Masami Isodha, okay, University of Tsukuba, and I am project overseer of the APEC lesson study project since year 2006. And in this lecture, I would like to talk about Japanese problem-solving approach. And it is a product of lesson study which realized on the textbook. And most of teachers know in Japan, many of teachers know Japanese problem-solving approach. Okay, and this is not as same as your meaning of problem solving, because as I explained it to you later, the Japanese problem-solving approach do not focus on the answer to getting the answer itself. Japanese problem-solving approach focus on problematic itself. Okay, through the problematic, student learns the content. We call that approach by the name of Japanese problem-solving approach. Okay. And there are some variations, and from now I'll explain. Okay. At first, Japanese problem-solving approach is a product of a Japanese lesson study. Okay, and Japanese lesson studies. If you see this slide, you see the class. And at the same time, you see the huge number of teachers. Okay? And inside of the class, okay, teachers are usually engaging in teaching activity, and the children are usually engaging in learning activities. And the topic of the teaching and learning is content or subject matter. Okay? Teachers have objective of teaching, and the children have the objective of the learning. Okay? If both objectives can synchronize, okay, the classroom activity is going very well. Okay? Such a situations can be explained this triangle. We call this didactical triangle. Okay? On the other hand, participating teachers, what they are doing, okay, what they are doing. And in Japanese Japanese lesson study, this size of the lesson study, this is national lesson study meeting. On the national lesson study meeting, every subject area working together. Okay, this is the science. Under the case of mathematics, we engaging in the lesson study activity in auditorium. Okay, the number of participating teachers are more than 1,000. Okay, what their objective of participation? Okay, they are focused on their theory of education. And as well as problem solving, theory, when I say theory of education, there are many misunderstandings appeared. Okay? Here I'm saying the theory of education for teachers, not researchers. Okay? Lesson study is done by the study SEAMEO. If we have the special study SEAMEO, we can discuss and we can share the theories of teaching. Okay? And what is the product of lesson study? Okay, there are various products. And the theory of education for teachers is one of the most key for the national level lesson study activities. On these lesson study activities, they share the theory of teaching. And the lesson study books developed by teachers usually share these types of activities. Okay? And how it is different when we compare with the lesson study activity with the activity of the researchers. Okay? For example, I'm a social scientist. Mathematics educators are usually a kind of scientist on the context of social science. Okay? For example, we write the protocol, okay, for explaining our finding to contribute to journals. And the nature of the scientist is that we have to find something new. Okay? On the other hand, in the case of teachers, of course, every participant realizes something new. However, they would like to share its most authentic and most essential theories for teaching, not really new. Really new means that other people never produced. Okay? If every teacher produces really new things, we cannot share. Okay? And it may not be the good theory. Okay? Good theory enables us to develop the good class. Okay? For producing the good class, we use that theory. So most essential and most authentic ideas will be necessary. So as for the social scientist, we usually produce the protocol for showing the evidence to write our research paper. And the research paper is necessary for the theory of education for social science. However, in the case of lesson study, classroom teachers do not never, if my understanding is correct, they never use the protocol. They use the dialogue style. What is the difference? Difference was very much clear. In Japan, lesson study began 1883. Lesson study, first book of the lesson study theories published at 1883. Okay, 140 years ago, more than 140 years ago, the theory of education for the lesson study already published. On that lesson study book, there is the two ways of describing the classroom. One is lesson plan, and another one is dialogue. Okay? Dialogue is not the same as the protocol. The reason why is that dialogue trying to show the ways of communication and ways of management. Okay? If you read the Plato, Confucius, and Imre Lakatos, okay? If you read those philosophers' book, you will understand what I'm saying. Okay? They never use protocol because at that time their ways of description is dialogue. Okay? They describe dialogue, but they are not really existing dialogue. This is the ways of description of the story. Okay? And the social scientists said the dialogue is not the science, really. I'm not sure social scientists say something like that or not. However, Aristoteles mentioned the episteme and the seime beyond the idea more practically. Okay? Episteme is academy, and the seime techne. Episteme and techne. And techne is a technique. And the social scientists said teachers are using technique. Okay? It is his viewpoint. And from what teachers, episteme is theory for teaching. And additionally, they have the technique. Okay? Depending on the standpoint, it is different. Okay? At the age of Plato, at the age of Greece, ancient Greece, Euclid was recognized as idea. However, Euclidean geometries now in current meaning not existed as an idea because that axiom was already denied at 19th century. Okay? At the end of 19th century, mathematicians produced new axioms already. Okay? For explaining Euclidean geometry currently. Already geometry itself revised. So on the processes, there are many theories are possible. Okay? Depending on the positions, we can produce our own theory. Okay? So what I want to say here on this slide is that participating teachers are really producing the theory of education. And this is the mindset of the lesson study. Okay? Researchers also participate, and researchers, of course, produce their own theory for the research. Both of them are theories, and we do not deny each other. Okay? We just recognize how our perspectives are not the same, how different we are. Okay? From now, we would like to show the video. And how to see the video, I have a lecture in others video which is explaining what is Japanese lesson study, what is lesson study. On that other video, I already explained how to see this video. Okay? However, it might be better you saw this video. And if you see this video, you may have good imagination of the Japanese ways of teaching. If you don't have see the good images, you may feel very difficult to understand my lecture. Okay. Okay. So please see the video. Okay. And if you saw the video, okay. My question is that there is the student who can make an order. Okay. And in many researches in mathematics education, problem solving is a heuristics. Okay. Of course, heuristics. However, shall all students have to find? Okay. Look at this picture. On this picture existed in the Vatican. It was written 16th century, 500 years ago by Raphael. And on this picture, the person who have the compass is Euclid, and others are student. Okay, students are talking about their finding, and in my interpretation, centers lady or boy find something and explaining it to the others. Okay. So this is the nature of the classroom, and this is the nature really images of 500 years ago's ways of learning of mathematics. Okay, someone find based on teachers' activities. Okay, okay. This is a national lesson study activities, and in our attached school, every year we have 2 times of national meeting. And on the national meeting, usually divided into the subject, such as mathematics, such as science. And in the case of science, the number of the teachers coming together is almost this size of numbers. And in the case of mathematics, we have the auditorium of the 1,200 people. And the whole auditoriums are occupied by the math teachers for the elementary. Okay? And they are talking about the something. Okay? And this is the difference when we compare with the other countries. Okay? And on that national level lesson studies, okay? And in the classroom, normally we discuss teaching and learning and content. Okay? On the other hand, so many teachers are participating. What they are talking about. Okay? What they are talking about is theory of education. And when we say theory of education, how do you say? Many other countries, researchers misunderstand. And many teachers also misunderstand. Theories should be developed by researchers. In Japan, if we say so, the people who think something like that cannot come into this room. Okay? Very difficult, because most of them participating in this room believe that theory should be developed by themselves. Okay? This is also deeply related with mindset of Japanese lesson study, to developing the children who learn mathematics by themselves, who learn science by themselves. Okay? They are coming together to produce their own theory for teaching. Okay? And for theory of teaching, they have the study SEAMEO. Based on the study SEAMEO, they engaging in the lesson study. For example, mathematical thinking is one of the shareable study SEAMEO. Okay? And when we say lesson study, there are various products. And one of the important products is theory of education for teachers. And I just want to distinguish how it is not the same. Researchers sometimes said teachers should be researchers. Okay? And from the lesson study side, we can say that researchers should be teachers. Okay? So, what is the difference? The difference coming from what is the theory. Someone said, my one is theory, okay? Your one is technique. And someone said, my one is theory, and your one is technique, okay? And depending on the person, the meaning of theory is different. Actually, Aristotle mentioned episteme and technology beyond the idea, more practically, okay? Euclid was known at that age as for the idea. However, Euclid mathematics are revised in the 19th century. Okay? So the theory also reorganized. So there are various levels of theory. Okay? So what is necessary for us is that in the context of lesson study, we produce the theory for teaching for ourselves. For doing that, we must need the schema of the lesson study topic. Okay? For the lesson study, we need the schema. Otherwise, we cannot produce the theory of education for teaching. Okay. For having the good images of the lesson study activities, please show the video, okay, on the YouTube. And I took another video of the lesson study. What is a lesson study? Okay. On that video, I will explain on this YouTube video. Okay. If you saw this video, you have some good images of the
now let's take a look at how they are implemented
Japanese
at the
lesson
school.
study activities. And on the Japanese lesson study activities,
is a second-grade teacher at
we
the elementary school,
usually
University of Tsukuba.
ask why. Okay? And on this video,
Mr. Sayama
one of the
thinks
most
that the students won't be
strange
happy learning
situation
unless
is
he himself is happy
student
about
can
teaching.
say wrong even if
What do
all
these students
answers
think
are
about their
correct.
teacher?
Why he can say wrong in that class? Another strange situation is student pose the question, how about the case of one? What will happen? Okay? Student pose the question in the classroom by themselves. Okay?
School is over for the day. It's now dusk, and Mr. Sayama is working
If
on writing something on the board.
we saw just this video only, it looks like very good student. Okay? Excellent student. And they well know the heuristics. And on the context of mathematics education research, okay, on the context of mathematics education research, we usually discuss about problem solving in which is related with heuristics. Okay, heuristics is very much important. However, in the mathematics classroom, it is not only the heuristics. Okay? Please look at this picture. These pictures are drawn by Raffaello in Vatican 500 years ago. And this is really 500 years ago's images of mathematics teaching. The person who have the dividers, he is Euclid. Okay? But he is not talking anything. He just trying to show something. And on that processes, students are observing. And my interpretation is like this. Center man finds something and trying to explain to the others. And the others are also trying to understand what Euclid is drawing and what their friends are talking. Okay? And this is the really images of mathematics teaching and learning 500 years ago. Okay? So we say the student-centered approach. However, teachers-centered approach itself is not really images of mathematics teaching at the 500 years ago. Okay? And what I want to confirm here is that why do we need the Polia? Okay? Did you have a chance to read the Polia? It's a very good book. However, my question is, do you really need? Before Polia quoted the Euclid, okay, and Pappus. At the age of Greece, Pappus wrote the treasury of mathematics in the collections. And in that book, Pappus well explained analysis and synthesis. And analysis is method of the finding, method of heuristics. And Polia tries to extend that ideas. And before Pappus, Euclid already wrote the name of the denomina. On that book, Euclid also known, he described the analysis. Okay? So analysis is well-known heuristics at the ancient Greece. And then Polia tried to revise that idea. However, who will revise for the classroom? Okay? What is the mathematics education researcher can? What teacher can? Okay, it is not the same. The theory of teaching is not the Polia, because Polia is mathematician. Theory of teaching should be written by math educators. This is very much important activities. Okay? And problem-solving approach, from now on, I will explain the problem-solving approach. And it is not just the problem-solving itself. It is not as same as problem-solving. It is approach for the teaching, the content, and approach for the developing the student who can think mathematically by themselves. Okay.